look at what is really behind KG, what KG is made up of. Here we see the KG box, the universal fault simulator. Okay. Then we have the KG terminals for taking measurements, and they come with masks for the different connectors in different vehicles. All right. Then we have the KG app, the software to configure, to program the different simulations that you want to run on a vehicle. And then we have the KG auto cables, which help you connect the KG box, the KG terminals to the different vehicles and the different systems on the vehicle. So we are connected here on the engine ECU, and we've taken the first connector here to plug us in. And we are effectively connected in series between the ECU and the engine. And we can see here on both sides, we have connections to the KG terminals. So we can take measurements on the ECU side and also on the engine side. And that's important depending on the direction of the signal. So when you have a sensor signal, that sensor signal is going to travel from the engine to the ECU. And when you have an actuator command, that command is going to travel from the ECU to the actuator. Okay. And then we can see here in the middle, this is where we connect the KG box. And we can see that there are different numbers on the cables. And this is going to basically tell us where to connect the KG box, depending on the function that you choose to use as a basis for simulation. So, the KG app is going to tell you exactly where to connect here the KG box. Okay. Now, if we look a bit more closely on the KG box, we are connected here, as I said, in the middle of the KG auto cables. We have also connected the negative, the mass of the vehicle to the KG box. This is important for simulations relating to short circuit to mass, and also voltage variation and PWM. So in total, you have 4 types of simulations that the KG box can produce: open circuit, short circuit to mass, voltage variation, and pulse width modulation. Okay. And we have connected the KG box to the internet, this time via a LAN connection, and we can see that it's connected here. We could also have connected the KG box via Wi-Fi connection, or even use our smartphone to create a hotspot. All of this is possible to do. If we are ever in a situation where we don't have an internet connection, the touch screen enables us to program a simulation as well. So that is also available as a backup when you're really in a situation where there's no internet. And last but not least, we have the KG terminals, which we can use to take measurements. As mentioned, we have these masks that help you identify the right pin for your measurements. And essentially, the KG terminals replicate the connector on the ECU, this connection. So yeah, it's a safe way to take measurements. You don't have to take measurements on the cables of the vehicle, and that way you avoid damaging the vehicle's cables. Yeah, it's a safer and a much more convenient way than doing this directly on the vehicle. Okay. Now, and last but not least, we have the KG app, and I'm going to try to share my screen now. So we have already prepared in the KG app our vehicle. In this case, we're on a Renault Clio. And we have also selected our connector, the 32 black. This is a 32 pin black connector. And we have set up 2 simulations here, which are related to the accelerator pedal signal. And the big convenience about the KG app is that you don't have to study the wiring diagram in detail to configure a simulation. All of this is already in the software. So we can just go into, for example, manual configuration. We can then see all of the functions that are available on this connector and select one from the list. And then we can select an action, a fault action from the list of actions, for example, open circuit, and click done. And I've already set up a new simulation. Okay, so it's very convenient and quick to do, to program a new simulation. The second advantage of the software is I can go into the playlist and I can actually store simulations in the playlist and then reproduce them for my training. So we have already saved some simulation in the playlist for this demonstration, and I can see them here, and I can quickly take them up again, right? Selecting on green, and done. And now I've added them to the list. So it's very quick and easy to program a simulation, configure a simulation from the KG app. I can click on done, on next, and now I'm on the last screen where I basically connect the KG app and the KG box. So first of all, I look here in the middle. We have already connected the KG box, KG47 in this case. Each KG box has a number, and you can see it on the KG box. It's easily available. And then, as mentioned before, the KG app tells us where on the vehicle to connect the KG box, and it's cable 2. So we have, if you remember from the beginning, we have numbers on the KG auto cables, and we have selected KG2, cable 2 to connect our system, the KG box. Okay, now let's look at this in real life. What's going to happen with this simulation? First, before we start, we're going to look at the healthy signal. So we're going to start the vehicle, and we've taken here the sensor signal of the accelerator sensor. Okay, so there's 2 sensors on the accelerator, and we can see that they react in simultaneously. Both absorb the charge from the accelerator pedal when I accelerate. And we can see that when I don't accelerate, they're at 0.7 and 0.4 volts. Okay, now let's keep that figure in mind, because that's something we're going to look at later. But this is the healthy scenario. And now we're going to activate the simulation by pulling the switch on green. Okay, we're going to basically activate an open circuit. So we're going to cut the signal of one of the sensors so that there's actually no more signal. And we're going to go on update session, and the simulation is sent. So now we can see I accelerate, and actually only the second sensor is absorbing the pressure. There's no more signal on the first sensor. We also see a notification on the dashboard that the injection is to be checked. You need to check the injection. And if we listen, we don't hear the engine go up anymore. The engine actually doesn't rotate up. There's no more noise we can hear. On the terminals, we can take a measurement and see on the terminals that there's no more signal on this pin, which is the pin H2. And that's what we're going to do now. We have here, again, we have ECU side, and we have engine side. We can go on H2, and we see open circuit. Okay. So this is also confirmed on the multimeter. Now I can undo the simulation. All right. I'm going to share my screen again. I'm going to undo the simulation, go on gray, update session, and we are back with the connection here. Hold on, I'm going to stop sharing my screen. And you can see we now have a signal that's going through. Okay? So that's an example of an easy simulation. Now, the big advantage of the KG app is that you can also, beyond just simulating a faulty signal, beyond just simulating an open circuit or a short circuit to mask, where you have no signal like now, or you have a signal when there's no fault. The KG app is also the KG box is also capable of simulating a faulty signal. So you can manipulate the sensor output. For example, in this case, we simulate a faulty sensor output of the accelerator sensor. And we have prepared this here in the second example. So we're going to apply now 1.5 volts instead of the healthy 0.7 volts. Okay. And we can now see we're 1.4, 1.5 volts. Okay. And we have on the dashboard again, notification. So we've effectively created a faulty signal from the sensor. So now we're going to look at this again on the KG terminals, and we can find these 1.5 volts that we've simulated. So we're going to go again on the pin H2, and we're going to go to the mass of the vehicle. And we have 1.5 volts. Okay. So this is something that basically you're creating a very realistic scenario that the learner can go through and will find the values that match the scenario. So you can really go from analyzing the symptoms of the scenario, taking stock of all the symptoms, developing a hypothesis of what could be the cause of these symptoms, then going to the diagnostic tool to get some further information about these symptoms and define the starting point. Take measurement with the KG terminals to eliminate or to compare these measurements with your hypotheses, and then eliminate based on this comparison some of the hypotheses that you've developed in the beginning to come to the right hypotheses and basically conclude your diagnostic process. So this is really a system that helps you go through a very realistic scenario with your learner on a vehicle with realistic values and realistic symptoms. Yeah, basically, if you have questions, now will be the moment.
And there was a question about just the ability to work on, traditional cars, on EVs and hybrids.
Yeah, so basically any low voltage system will work. So this can be traditional car, but also electric vehicles and hybrids. So there's no limitation on that as long as we stay on low voltage systems. And we're not only, this example is on the engine ECU, but we also have clients who use it on other ECU. The system stays the same, only the connectivity, the connectors will change based on the ECU we'll work on.
Thanks, George. There's another question around the ability to use this in parallel with other vehicles. So if they had, multiple vehicles, how would that work?
So the great part about the KG app is that it can control multiple vehicles in parallel. So one KG app access, so you from your computer can control multiple KG boxes and therefore control scenarios on multiple vehicles in parallel. So what many of our clients do, they set up groups, one group per vehicle, and then they have a list of scenarios that they go through per vehicle. And these scenarios can be different from vehicle to vehicle. All of this you can control, you can configure from the KG app. And so in line with the progress of the learner on that vehicle, you can activate and deactivate the scenario and then move to the next scenario. So absolutely, this is a great way to create different scenarios and do training on multiple vehicles in parallel.
Thanks, George. There was a question about the length of the cables. And I don't know if those are standard, just basically the run between the box, the terminal, and the car.
So we've made them longer because typically what clients tell us, they want to put the box away. So the learner has no idea that this is happening here, even though there's nothing visible on the box while you use it on the software. But yeah, this is basically, we can make them shorter if this is more interesting for you. Basically, we just want to give the option to our clients to put this further away if needed. But this can be shorter if that's interesting for you guys.
The next question was really to kind of recap a little bit on the ability to share across the department. So, for example, Steve at Columbus State's got, gosh, 5 or 6 folks that he works with. And so that entire team would have the ability to share in the playlist of scenarios set up? They want to get a little clarity on that.
Yeah, so basically, when we set you up on the KG app, we set up an account for your organization. So for your whole school or college, and then every teacher in your organization has access to your account on the KG app. So they can all feed into the KG app and save the simulations, save the scenarios that they're using in their classes. And then they can share it that way with their colleagues. So everybody feeds into the library that is associated with your account for your association, for your organization. And then everybody in that account, so all of the teachers in the school have access to these simulations. So a great way to share simulations among colleagues and share knowledge between different trainers. Yeah.
This one I'm gonna read directly from the quote from Steve. This is great functionality for a breakout box. I didn't catch if you can do that do an offset voltage. Say it has a normal sweep of 0.5 to 4.5 volts from a sensor, and I want it to be offset by a percentage or voltage so it reads 0.5 to 2.25. Can we do
So
that?
basically, what you do with the voltage variation, you set the voltage that you want to simulate. So basically, you will look at the vehicle and say, okay, this vehicle, the basis voltage on this vehicle was 0.7, 0.8 volt on the sensor. If I want to offset it by 0.5 volts, I need to put it to 1.3. Okay, so you can configure that. You can basically go in decimal intervals, so from 0.1, 0.2, 0.3, and configure it in the way that you need for your vehicle. But it will not automatically recognize what's the basis signal. You need to configure what kind of output signal you want to have.
There's another one, a question around, is this available for all cars, US cars, but which are there certain cars it doesn't work for? So basically a question around the kinds of vehicles it'll work with.
Well, all vehicles really. So we have, basically the only thing that changes is the connectors, and we have partners who are specialized in this area to provide the necessary connectors, also for US brands, for GM, Stellantis. So whatever vehicle you have, we will provide you with the connectors.
And a question also, this individual does, you asked about with trucks regards to any heavy equipment. Just want to clarify how far up the food chain it goes vehicle wise.
So yeah, we have absolutely got clients who use it with trucks. Notably, for example, Volvo Trucks is using it. We also have schools who use it with Renault trucks, and soon we'll have a client for MAN trucks. So absolutely, the solution is also ready for trucks with the 24-volt systems. The box stays the same, so you could even switch from a truck to a car. That's not a problem. And we provide also the necessary connectors for that. So we designed the system to be compatible not only for cars, but also for trucks. Yeah, even tractors. We have some agricultural schools who use it on tractors. It's also more complex than you think, a tractor today.
Yeah, I think we actually had somebody from John Deere joining, so that'll be good for them to know. Awesome.
Yeah.
There was a comment that, some ECUs are harder to reach than others. So I don't know if you've discovered ways with regards to how KG might work in those situations.
Well, I think the easiest way to work in those situations is to really unplug the ECU from the vehicle and take it out. So it will still work. You can leave actually the auto cables connected because we take all the connections of the vehicle. So I think if you have an ECU that is difficult to access, that will be probably the best solution for that scenario.
Thank you, George. One more question that I'm scanning that I haven't asked you yet. It was more about just in your experience, how has the learning curve been? In other words, as an educator who's been teaching this, under the hood for years to kind of embrace this approach, how have you seen the learning curve for those people that embrace and start using KG?
Yeah, that's a very good question. So most of the trainers who start using our solution are at first a bit skeptical about the software because they're not used to doing things that way. But very quickly, once they start configuring one or two simulations, they see that it's actually a very quick process and that it helps them a lot. And then they start playing around, right? They start configuring things and they test how the vehicle react to that. So it really brings out their playfulness, let's put it this way, because it's so quick and easy to test different scenarios, and that's the big change to what they experienced, what they're used to, right? And then the second point that they tackle after that is taking measurements. So that's the second thing that they get used to.
Great, guys. Well, if you need more questions, you're welcome to post them on the chat or again, come off mute. Here's another one. Did you have any plans to expand the logic capability by modifying the CAN messages? Can you consider programming it to output a bogus CAN message when it gets a certain input CAN message?
So our system is designed around the concept that we manipulate the communication that goes between the ECU and the different sensors, actuators in the vehicle. Okay, we don't go into the ECU, and we don't go also into protocols. So the CAN protocol is a protected protocol, and we can simulate our 4 actions there, but we don't configure a faulty protocol message on the CAN or the LIN bus or any other data bus in the vehicle. So no, that's not part of our technology, because it's also protected by the manufacturers.
Actually, thank you, George. Nice build off of that. That question around the impact on warranties. One individual here says they have they're blessed with a number of loaners from nearby dealerships, and they want to be cautious of any warranty impact. So, do you have you can comment to that?
Yeah, so basically this is a very good way to keep the warranty of the vehicle, because you're not cutting any wires, you're not implementing any faulty parts. You're really just sending faulty information from or to the vehicle ECU. So we see this a lot also with clients who use trucks, because a truck is much more expensive than a car. So many of the truck schools that we work with, they have to send the truck back to the dealer, and then they like to use our solution, because today, when they do this manually, they are much more limited in what they can do, because they have to be worried about the warranty. Now with us, they can really create more complex scenarios than they could do today, because the warranty is still intact. So there's no impact on that. And I've done this on this vehicle many years, and they had service with it, and there's been never any comment from a dealer to say, oh, there's no more warranty. So absolutely, this is a good solution for those people who have rentals.
Yeah, it's a good point. Actually, it puts less wear and tear on the components in the vehicle, because you're not poking, you're not prodding, you're not putting holes in them. Good point. Okay.
Absolutely.
But I really appreciate you guys joining us today. I know it's a Friday, end of the spring term. George, I'll give you the last comments. Any thoughts?
Yeah, my last comment is basically, if this is interesting for you, I think the next step for you would be to send us the pictures of your connectors, because that's how we can prepare a quote for you guys, and that works for your vehicle, so that we have all the information. And you should go to Edtech Global's website, leave your details there. You can also upload the pictures of your connectors, of your vehicle connectors on the site, and then we can get back to you, or basically your local reseller will get back to you with a quote for that. So that will be the next step for you guys, if you found this interesting, if you think this could be helpful in your context, in your school.
Perfectly said, George. Thank you so much. And as a recap for everybody, I'll make sure everyone that attended, I'll send you a follow-up. Thank you for joining. If you want a link to the recording and also a link to the Edtech Global site, as George has said, there's a really nice slick form that allows you to enter your information, the vehicle information right there, including pictures of your ECUs, and we can make sure we specifically design what would your vehicle's cables look like. So with that, George, thank you so much. I know it's a little later over there in Paris, but appreciate you making time. And Manu behind the camera, thank you so much, guys. And for all of our attendees, thank you, everyone. Hope you have a great Friday and a great weekend.